And we should be live. Just gotta finish setting up YouTube. Here we go. Pop out chat. Sorry, I'll start answering questions in just a moment, y'all. I just gotta finish setting things up. All right, we should be good to go. Right, hope everybody's having a good day. We did just start the live, so, you know, feel free to ask your questions. You'll get your answers in early. Howdy, howdy. Hope everybody's having a good one. Make sure that Ian needed me yesterday. What did he need me for? Am I back from my trip? Yes. Do photons experience time? This is a good question because it gets talked about a lot. And if you've seen the, you know, there's like the Reddit meme with like the bell curve where it's like the dumb people are on one side and then the medium people are in the middle and the high end people are saying the same thing as the dumb people, but they're on the other side, like the high IQ people. The thing is the standard science communication line is that photons don't experience time. The correct GigaChad based science communication line is that of course they experience time, just not proper time. They experience affine time, which is true. You can affinely parameterize the photon world line, and then yeah, there definitely is a notion in which there's a past and a future. There's just not a way to tell how much time has passed, but you can definitely distinguish between the past and the future on a world line for a photon. Do you ask in chat or join some VC? Yeah, ask in chat. How was the trip? The trip was really good, although the jet lag killed me. I'm still getting up at 4:15 in the morning. Did you ever figure out the problem with virtualization? Nope, not resolved. Turns out it's not really necessary. So I'm going to put off that problem to later. How do you think the universe will end? At this point, I'm pretty agnostic about it. I just don't know. Assuming we had an object with infinite rigidity, would it get spaghettified by a black hole? Once you start invoking infinite rigidity, it's just not compatible with relativity anymore. So it's hard to say. Is the universe the only physically infinite thing? I mean, it's hard to even say that the universe is a thing. In some sense, you could say that it's like maybe it is spatially infinite, in which case then it would be. Yeah, I don't really know what you mean. Affine, A-F-F-I-N-E. You're not physicist. Sure I am. How is string theory a theory if you mentioned that it does not have evidence? So string theory is a theory in the mathematical sense. So string theorists, so mathematicians use the word theory to describe just some sort of kind of like a framework in which you can do mathematics. It's not a theory in the sense that like science communicators use the word, where it's like a model that has been supported by evidence and so on. It's just a different use of the word. Is it true photons gain mass when interacting with the Higgs field? No, so photons don't interact with the Higgs field. That's the point. That's why they have no mass. Do you supplement your physics with philosophy? Occasionally, yeah. Have you watched the show Three-Body Problem? I have not, and I don't plan on it. Nobody on Fire sent the $2 super chat that I missed. The man, the fact, the doctor. I appreciate that. Remember, super chats do get answered first because, you know, if you're going to send me money, I may as well do you a favor. How do I understand relativity without being overwhelmed? Learn some linear algebra. That's usually the best way. Can you clap with no hands? No, I cannot. Have you ever thought of a function which gives an output without giving an input? Then it wouldn't be a function, right? Why is space black? It's actually an interesting question. It's related to something called Olber's paradox. The idea is that if the universe were static and if it were finite in size and if it were infinitely old, then the space should look pure white, the color of stars. However, the fact that it's not pure white means that one of those three things can't be true. In fact, it seems like all of them are not true. The space does not seem to be finite in size. At least it seems to be expanding. It does not seem to be infinitely old. At least stars are not infinitely old. And because it's expanding, it's not static. What do you think about the theory of our universe being in a black hole? I think you can actually prove that it's impossible if you assume standard general relativity, which I'm going to work on. It's a thing that's been, I'm working out the details in the back of my head. What is 3i Atlas really? Like, no diplomatic answers? It's a comet. It's a comet. Of course it's a comet. Weird Q based on your last video. Why is 10 to the minus 14th the demarcation of time for an element to exist? Yeah, so that's what I read online. The justification is that that's how long it takes for a nucleus to grab electrons and for those electrons to basically form something that's not just a nucleus. So in order to have an element, it needs to be electrically neutral, or at least have a low ionization number. And so that's roughly the demarcation limit, where if it exists for less time than that, it's just not enough time for the electrons to kind of bind themselves to the nucleus. Do you believe in aliens? Almost certainly they exist somewhere in the universe. In fact, they may have existed on Mars, but I don't think that they've ever visited, no. How can an electron have a structure when it has no mass? You're getting it backwards. Electrons have mass, but no structure. They don't have subdivisions. And it's weird, but that's just kind of like what the experiments say. What's your take on the trolley problem? I would probably freeze. I'm still serious, Blitz. With the $10, Z08840, thank you for the $10, by the way. He says, I'm still serious, Blitz, God experiences in affine time. I mean, like, that's a conversation that you could have, I guess. You'd have to build a theory. Why does God have affine time? Like, there's a whole thing like that. But what do you think happens to the material inside a black hole? So I suspect that what's happening inside a black hole is that there's an ultra-dense form of matter that lives there, and maybe it's bouncing off of that in some very, very time-dilated sense. I really don't know, though. It's speculation. What's your outlook on beginning of the universe, or is not something you think is important due to how hard it is to solve? No, I think it's super important, and it's one of the things that I'm interested in working on, and something that I recently wrote a paper on, sort of. I don't know if our universe had a beginning or not, if time had a beginning. It's something that I'm actively thinking about. Can emergent gravity models reproduce all tests of general relativity? I suspect not, because emergent gravity models are generally really, really hard and still really, really basic. Most of the time, emergent gravity will reproduce Newtonian stuff. So like entropic gravity reproduces Newtonian stuff, as far as I know. Like this Berlin's entropic gravity. What would happen if I put H2O in a box, but it didn't have any room to expand and then it was frozen? It would either, so as it was trying to freeze, the box would, if the box was indestructible, the box would apply more pressure. And so that would just cause it to change phases. So essentially, if the box wasn't strong enough, then it would expand and it would break the box. If the box was strong enough, then it wouldn't expand, and instead you could reduce the temperature further and further until you get to some other phase change where it turns into another form of ice. There are forms of ice under extreme pressure that are more dense than liquid water. It's just we don't usually see these because they don't form at atmospheric pressure. I was recently reading about virtual black holes and came across something contradictory. They don't affect their surroundings, but provide a pathway for proton decay. Can both be true? How? Yeah, so virtual black holes are an idea. I don't know. I'd have to look in specifically at what you're thinking about, or what you read, because it's really hard to say. Virtual anything in some sense are not real, depending on your preferred interpretation of quantum mechanics. What it is it's kind of like a decay mode. And you could have a proton like kind of pass through a virtual black hole intermediate phase or intermediate step and then decay into whatever. But it's really, really complicated. We're starting to get into the realm of quantum gravity, and we don't have a whole lot to say about that that's actually grounded. Does your view of black holes disagree with Penrose diagrams then? Well, Penrose diagrams are just useful if you just take GR seriously. And then you continue if you take a Schwarzschild black hole is defined as a vacuum solution. So if you use the Schwarzschild metric, then the Schwarzschild metric says that there's no matter in the interior. However, if you assume that there is matter, some ultra-dense matter or something, then the Penrose diagram will be different. What if theoretically atomic bombs explode inside of a small indestructible box? Then the box would be fine? What about wormholes could be actual cause for particles have mass? Can you explain it? I've never heard that claim. I'd have to look into it. Neutrons decay into protons. Where does the charge come from when this happens? It decays into a proton, an electron, and an electron antineutrino, so the charge is still conserved. Where does the sun go at night? It goes onto the other side. Black holes don't exist just like space, only unproven theories. Okay, bud, whatever you say. Since you're an atheist, do you think there could be an afterlife with no God? I don't really think so, but it's not really related to the existence of a God. If you go through a black hole, your spiritual energy gets portaled to the 6th dimension. What? What explosion is expansion if explosion doesn't have space to expand? What explosion isn't expand, like a nuclear explosion is just like a rapid conversion from nuclear binding energy to electromagnetic energy, right? It doesn't have to expand, it's just that's usually what happens for thermodynamic reasons. Is chaos without time at the speed of light ageless or time? I don't know what that question means. Do you believe time is our 4th dimension? Time is one of four space-time dimensions, yeah. I'm interested in time. I feel the future can be accessed, but not a past event. What? Do you think electrons exist? Yeah, sure. Absolutely they exist. Is quantum tunneling true? Yes, it is. And in fact, I have an upcoming video that's going to calculate what the probability is of your hand passing through like a centimeter of wood via quantum tunneling. Do you think super small black holes exist? Depends on how small. It seems plausible, but we don't have any evidence that supports it right now. Can people have their own space-time? Space-time is everywhere. There's not individual space-times, right? Is data transferred via quantum entanglement traveling faster than the speed of light? So you can't transfer data via quantum entanglement. There's something called the no communication theorem that makes that impossible. From Nobody on Fire with the $2, thank you so much. Why are wormholes impossible to keep stable? So there's something called a Cauchy horizon in a wormhole. And essentially what that would do is any incoming anything would essentially be blue shifted. So when things fall into a black hole, their energy basically gets ramped up because they're gaining energy as they fall in. That's what blue shifting is. Sorry. And wormholes necessarily have a Cauchy horizon. And the trouble with the Cauchy horizon is that they would blue shift things to infinity, which means that anything that falls in is going to dramatically change the gravitational behavior of the area because things gain so much energy. And so just like all of the small changes become huge changes. And so that's kind of the definition of instability, right? One of 4 space-time, what are the other 2? Well, so there's 4 space-time dimensions. Our universe has a 4-dimensional space-time, at least as far as we can tell. 3 of them are spatial, 1 is temporal. Can you explain what strangeness is? Yeah, so strangeness in particle physics it's basically a feature that certain quarks can have. In particular, there's only one type of quark that can have the strangeness feature. It's the strange quark. And you can sort of think of strangeness as a conserved quantity. So if something has 1 strangeness or -1 strangeness or whatever, then that is conserved except under weak nuclear force interactions. Then strangeness conservation can be violated. If energy and mass are equivalent and mass generates gravity, does energy also generate gravity? Would photons have really small gravitational fields? Yes and yes. In fact, the thing, at least in Einstein's field equations, which is how we understand gravity nowadays, it's energy that does the gravitation, not mass, at least not mass directly. Like there's not really, I mean, like mass is related to energy via E=mc² and so on, but it's the energy that actually plays a role. It's energy density. PhD in theoretical physics here, love what you're doing. I appreciate that. Why does no one speak of white holes anymore? Because they're almost certainly not real. Is it true that knots only exist in 3 dimensions? Yeah, so in 4 dimensions, knots are one-dimensional knots are topologically equivalent to circles, one-dimensional circles. They're like a loop that's just twisted a whole bunch. And in 4 dimensions, you can always undo those. Now, you can make knots from 2-dimensional sheets that are twisted, like a 2-dimensional sphere, and kind of like drag it around. You can make knots that way in 4 dimensions, but a standard knot, a 1-dimensional knot, you cannot. See what I did there? What's so charming about the charm quark and why the strange quark's so strange? They're just names. They're just names. What is the universe expanding into? It's not expanding into something. You shouldn't think of the expansion as like the edges are getting further away and thus filling some new gap. You should think of the expansion as a local thing. So if you have a certain amount of space, in 10 billion years, you'll just have more space in that space, which is weird to think about, but that's the way that's how you should think about it. From Ivan with the $5, if I were to throw it back in a circle, the resulting physics would induce false vacuum decay. True, it would, yeah. Is the momentum photons have additive? Well, yeah, momentum is an additive property. If faster than light were possible, what would it look like? I mean, in principle, you could see it, but it depends on how you're doing it, I guess. Buoyancy and density explain gravity. Have a nice day. Well, I mean, that's not really true. But if you want to think that, by all means, I guess. Have you ever read Flatland? I did when I was a teenager. I thought it was brilliant. Like, it's a great book. How does space come into existence before material? I don't know why you would think that that happened. Dr. Blitz, can you explain the recent discovery W-state identification? I haven't heard about that. Sounds like a particle physics thing, though, which I can look into. Do you have a job outside of being a physicist? Being a physicist, in some sense, is a job. You spend time doing research. But so, you know, I'm a researcher and a science communicator. Those are the two things that I spend my time doing, and that's how I make my money. How many hours do you study daily? I wouldn't call it studying, really. Like, I do research, like that's part of what I do every day. If that counts as studying, then like 5 to 6 hours. Depends on the day, I suppose. Nobody on fire with the $5. Watched your TikTok video. Is there any reason behind the seemingly assumed correlation between element 144 and anti-gravity drive akin to Bob Lazar? So the thing about Bob Lazar is element 115, not element 144. And we've made element 115, and it has none of the properties that Bob Lazar said it has. So he was just wrong. And of course he was wrong. He doesn't know what he's talking about. If you spam, by the way, whether you're on TikTok or on YouTube, I will have to mute you, so please don't spam. Does the center of mass of Earth change constantly, so fractionally changing the orbit of the moon? Well, okay, yeah, so the center of mass of the Earth does change, I guess, a little bit, like when earthquakes happen. But I don't think that it changes significantly enough that it changes the orbit of the moon. I could work that out, but like nothing that really happens on the surface of the Earth is really significant to the Earth as a whole. If you theoretically push something with negative mass, would it go towards you? Yeah, it's weird. It depends on what kind of mass. If we're talking about negative inertial mass, then yeah, that would happen. If you're talking about negative gravitational mass, then not necessarily. It could still have positive inertial mass. Sorry, I've had this weird cough for like a day or two, and I don't know what's going on. Can you walk us through a little bit of how you conduct your research on a new piece you're working on? Yeah, so it really depends on the thing. So there was a paper that I wrote in July, which is currently under peer review. That was sort of kind of an idea that it started as just an idea that I was toying around with that was kind of built on a paper that another author wrote that inspired me to consider kind of like the same thing but for the whole universe. And so I started just fiddling around with ways that I could make the idea work. And there was a lot of things that I didn't know. So I had to go like basically digging to see if people had solved like this little piece of the problem or that little piece of the problem or that little piece of the problem. And then after I'd found all of the ingredients that I thought would be necessary, then it was basically a matter of putting those ingredients together and then doing the calculations to verify that indeed the thing that I thought would happen actually does happen. And then it's a matter of writing it up. Now, on the other hand, there's another paper that I'm working on that I started writing on Thursday. This was essentially an idea that I had floating around in the back of my head for a few years, but I had never come up with a way to kind of solve the problem. This is a math project that I'm working on. Basically, I was trying to prove that a particular type of object doesn't exist. And I had good evidence that it doesn't exist, namely all of the methods I would usually use to construct the thing didn't work. But I didn't have a proof. And then I was at a conference last week, a mathematics conference, and I spoke with a few colleagues. And from the conversations that I had, basically I got the right inspiration to come up with a clever, I don't know if it's a clever solution, but come up with a solution that does prove their non-existence. So I've kind of been frantically writing that up so that I can have it on my CV before I apply to jobs again. All right, we got a $2 super chat from Daniel Rathbun. Do you think a matter replicator is possible? So like, it's in principle possible, I suppose. But it seems like just from E equals mc squared, the amount of energy that you'd have to have flowing through the thing would be enormous. So I suspect it's like impractical. Yeah, by the way, if you're watching on TikTok or on YouTube, make sure to like, share, subscribe, follow, join the Discord server. There's links in the description, links in my link tree, all of these things. And if you want to support me, there are ways to do that. There's a Cash App. You can send super chats on TikTok. Sorry, super chats on YouTube. Plenty of ways to support me if that's something that you're interested in. Why do photons display momentum while massless? Well, it's merely the case that things don't have to have mass to have momentum. That's the only reason we have the intuition that momentum requires mass, is because we're used to thinking of like slow things that Newton talks about. But Newton is just a low speed approximation to the actual physics of the universe. When's the follow-up video to the guy claiming bells have destructive powers? I don't know which video you're talking about. Are there elements out there that we haven't discovered? So plausibly. So the way that the periodic table is organized is that there is one element for each number of protons that an atom can have. So we've discovered all of the possible elements that can exist up to 118 protons in the nucleus of the atom. And so there's not really anything we could be missing, because something can't have 1.5 protons, right? It can't have 39.5 or 39 or 46.2 protons. Protons come in whole numbers. So we know all of the elements up to 118. Now it could be that there are elements that we haven't produced yet that have more protons than 118. But these are all going to be synthetic. Almost certainly they don't exist in nature because they're so unstable. A question to Blitz: do physics jobs in general pay well, or is it barely enough? It depends on what your position is. Grad students you don't get paid a lot as a grad student. Postdocs, you'll make enough to get by. It's weird how much you get paid considering how advanced your degree is as a postdoc, but in the US you might make 70K. And professorships generally, again, depending on where you are, you generally make enough to get by, enough to be comfortably middle class, 100, 120K or something like this, depending on where you live. From Grimlock with the $5, thank you for always answering my dumb questions. Hydration, yeah, thank you for the reminder. Do you believe in the island of stability for elements? It's possible. I think that, so if I were to place bets, and this is just solely based on being like kind of generally skeptical and generally conservative in my views, not politically just, reserved, I would suspect that the island of stability exists, but these elements are not ultimately stable. Merely, they are just more stable than their neighbors. So we might be able to produce some elements that last for a day or a week or a month or something, rather than half a second. And that would be fascinating if true. How is 100K per year middle class? Well, it depends on where you live, right? So I was offered a tenure track position in Alabama 2 years ago. I didn't want to move there, so I turned it down, and that was 75K a year. However, if you look for tenure track positions like professorships in California, that's going to be 140K a year in, say, Los Angeles, or 150K a year. But it just depends on where you live, right? 75K a year is comfortably middle class. That's like, perhaps even upper middle class in a fairly rural part of Alabama. In Los Angeles, that's not. Just look at housing costs, right? Times have changed. What value does a physicist bring to be worth 100K a year? So generally, professors at universities are teaching students, and these are teaching generally engineers. And engineers need to be taught by experts so that they don't make mistakes when building bridges. So you want to be paying enough that you can, convince highly qualified people to do that rather than just go working in industry. Yo, Unc, are you a millionaire? I'm not, no. If I want a job in physics, what should I do, professor? Well, I'm not a professor. I have a PhD. I'm a doctor, not a professor. Professor is an academic title. I don't have that title. But if you want a job in physics, you're going to need physics degrees, right? Do you think the Big Bang happened not only one time? I don't make any claims. Everything about that would be speculation. Is there anything that can be caught up in my own personal gravity? Not really, not unless you're very far away from everything. And then, yeah, sure, things could orbit you. What mathematics should I teach myself if I'm able to in order to understand things like relativity? So for special relativity, essentially what you need is linear algebra and calculus. That's basically it. So physicists just teach engineers? Well, so the job of we're talking about professors here, not all physicists. Professors, physics professors, their job is about, depending on where you are, somewhere between 1/3 to 2/3, somewhere between 1/3 to 1/2 teaching, right? You spend about about 30 to 50% of your time teaching, and then the rest of it is doing research or service or outreach or things like this. And that's the part that pays the bills, essentially. And the thing that attracts good students is the quality of the research that you produce. So a university wants to attract good students because then it makes their university look better, which means that they'll get even more students. So they want to have people who do good research so that they can attract the good students. And then those researchers then also convey their expertise to their students so that the students get something worthwhile out of it. It's a whole, there's a lot of exchange happening. If you make a radioactive element very, very cold, like very, very close to absolute zero, would it slow its radioactivity? No. No, it wouldn't. So, yeah. I guess the answer is just no. How do you read so fast and don't stutter? I do stutter. It's just not when I'm reading. If you had to choose a career outside of physics, what would you choose? Mathematics? Right? Oh, did I miss a super chat? I may have missed a super chat. Oh, no, I didn't. Okay. Why is only americium used in smoke detectors? That I don't know the answer to. I suspect because it's not so hard to make, it lasts a long time and it's an alpha emitter, but I don't know. I actually don't know. Do you think the Big Bang was the releasing of negative charged ions, almost like a black hole, and then those ions attract other ions? No, it wasn't that. Too many questions for one person to answer. 1 minute a question. This can take a long time to get to mine, I guess. I just try to answer the ones that pop up. Sometimes I'll miss some. What do you think is the most efficient energy source humans could use? I mean, if we can make nuclear fusion work, then we will. Other than teaching, physicists seem to bring little value to society, just critically thinking aloud. I mean, if you thought that, then you would have to, think that lasers are useless, MRIs are useless, semiconductors are useless, the internet is useless. Like there's a lot of things that were built by or that were invented by physicists as part of their job. Nonlinear optics, tons of things, right? GPS. When do you think the technological singularity will occur? What do you think that means for humans? I don't know if the technological singularity will occur. Who knows? Are perpetual motion machines truly not possible, or is there a chance we can invent one? No, at least if you think that the laws of physics are laws, then no, they're not possible. The second law of thermodynamics forbids it, and the first law of thermodynamics for that matter. Daniel Rathbun with the $5. Wait, you mean to tell me that being smart doesn't equal big money? Next, you'll tell me that Katy Perry is a millionaire. Yeah, well, that is true. What are your thoughts on 3i Atlas? It's Comet. Would a series of absurd coincidences lead you to believe in higher power? It depends on how absurd they are, I suppose. And if they happen to me, maybe. Who is the greatest physicist of all time? It's probably Einstein, with a very close runner-up being Newton. What is gravity? Is it a force or space-time curvature? It's both. So space-time curvature is the most accurate way we can describe gravity right now. But that still makes it a force, considering that all of the other forces are also the curvature of something. We describe electromagnetism as the curvature in a U1 gauge bundle. We describe the strong nuclear force as the curvature in an SU3 gauge bundle. That's what forces are. Forces are curvatures. Final attempt, do you frick with Metal Gear Solid? I've never played it, but I'm familiar with it. Are you a physics teacher? I mean, in some sense, that's what this is. But no, I'm not. I don't work at an institution. Well, okay, kind of do. But I don't teach at an institution, I should say. Do you think we'll ever discover a white hole? I suspect not. If they did exist, then we'd probably have already seen them because they'd be very, very bright. Einstein stole material? I don't think he did. Hey, brother, can I get a shout out? Jack, this is a shout out. Do you believe or know of physics underneath or above our ability to observe the universe? I don't know what that question means. Will we ever send a person into a black hole? I would hope not, unless it's, willing. Can you give some insight on virtual particles, virtual particle, antiparticle? They're math juju. Maybe that's an insensitive word. They're basically made up. They're a math trick. And because they're such a useful math trick, people have started to assume that they're real. Have you met any modern day big name physicists? I have met Edward Witten, who's the string theorist. I've also met Roger Penrose. I got a selfie with Roger Penrose last fall, I guess. Yeah, so that was cool. He didn't seem too happy to do the selfie, but he was like obligatory, What % of credibility does the move Interstellar have? It has a lot of credibility, except the last 15 minutes or so anyway. Would you recommend a career in astrophysics? Not for the money, but if you love it, then you love it, so you do it for the love of the game. Do you think we live in a simulation? I don't think so. I think that there's good reason to think that it's not possible for us to simulate a universe like our own, so there is therefore good reason, or there's no good reason to think that we ourselves are in a simulation. Why is general relativity non-renormalizable? It's essentially the nature of the theory. So first, it's that its gauge group is not finite. It's not finite dimensional. That doesn't necessarily make it non-renormalizable, but it definitely doesn't help. The second thing is that it's like super, super, super nonlinear. It's like as nonlinear as it can get. Why didn't matter and antimatter form in equal portions? If I knew, I would be going and getting my Nobel Prize, right? Do you think information could be stored in some kind of hidden degrees of freedom? You mean like for like quantum entanglement stuff? No. Is Ed Witten a mathematician, or was he a physicist who won a Fields Medal? Yeah, so mathematicians would say he's a physicist, definitely. But as far as physicists go, he's probably the most talented mathematician. As far as the famous physicists you've met, are they arrogant? No. Did you do a postdoc? Yep, I finished a postdoc at the end of April, and now I'm on the job market again. What's your advice on how to get over a toxic ex who can't get off your mind? I don't think I'm the right person to ask for that. How smart is Ed Witten? He is so smart. Can a multiverse exist? At least in principle it could, but we don't have any evidence to support it, at least not like the cosmological kind of multiverse. What's wrong with the electrostatic universe theory? Well, it doesn't account for the gravitational observations that we make. What do you think will happen first, a quantum model for gravity or the winds of winter releasing? Oh, probably a quantum model for gravity. No, that's a joke. Well, probably not. Could large files be sent through space using light, like at the speed of light? Yeah, sure. How will engineers get past the quantum tunneling problem with transistors in order of nanometers? I don't know, but that is an engineering problem. Can you explain what is the rate of time? I mean, what is the speed of time? Well, speed is measured in something per second. And so if you're talking about the speed of time, that would be in seconds per second, which is just one. It's just a number. Have you met any other chemical physicists? I've never met any chemical physicists. Where do you think the fundamental laws come from? I don't know. Have you engaged with astrobiology at all, like Dr. Dakota? No, I haven't. It's interesting, but I don't really care about exoplanet astrophysics. Are antiphotons theoretically possible? If they are, what properties, effects would they have? Antiphotons are photons. Photons are their own antiparticles. Do you think we'll ever be able to teleport water? I mean, I guess in principle, I don't know why you would want to. Thoughts on dark matter? Almost certainly a real thing. I would suspect it's some kind of particle we haven't detected yet. Is it true they found new types of black holes? Not that I've heard of. Can you define what a field is? I really want to understand this concept. Yeah, so a field is just, it's a mathematical rule of assigning a value or like a vector or assigning something to every point in space-time. So maybe you assign a number to every point in space-time. That would be a scalar field. So like the Higgs field is a scalar field. And so there's just a value that you can assign to every point in space-time, every possible position and moment. That is the value of the Higgs field. From Nobody on Fire with the $5. Thank you so much. I appreciate it. If quantum entanglement could be used to transmit information somehow, would that mean information is stored in the spin of the balls? Yes, that is true. It would be stored in the balls, in the spin of the balls, if you will. Teleporting water would be handy in colonizing other planets. So the way that we know how to do quantum teleportation is you have to have something at the other end to build the thing. The quantum teleportation is just when you basically teleport the quantum state. You don't actually like move the matter from place A to place B. You are so smart. I mean, who else claims to be a physicist but plays on TikTok every day? Well, so this is how I do science communication, and it's part of my income. So that's why I do it. I also think it's valuable to do outreach. So if you have a problem with that, That's on you. Does every point in space-time have its own unique observable universe, even if they're very similar to each other's? Yeah, in principle, yes. How did they figure out the formula for Earth's gravity? Do you mean the 9.8 meters per second squared? That you can just measure. But if you're talking about the formula for like Newton's formula, where it's the gravitational constant times the product of masses divided by the radius squared, that I actually don't know what the process Newton used to come to that formula. I don't know off the top of my head. That's a historical question though. What does it mean to be a physicist? Well, I would say that being a physicist is part of the job occupation is that you do physics. You conduct physics research, or you investigate physics questions as part of your occupation. Are you a theoretical physicist? The word I typically use is mathematical physicist because in some sense, I am more of a mathematician than theoretical physicists are. I spend more time thinking about things mathematically rigorously rather than thinking kind of from the seat of my pants, if you will. If two black holes collided, would the bigger one eat the smaller one? Yeah, in some sense, but they kind of just merge rather than one eating the other. What's this I heard about the double slit experiment finally being confirmed recently? Well, it wasn't recent. It was in like the 70s and 80s. But yeah, before that it was considered just a thought experiment, but everybody knew that it would be confirmed. It was just a matter of actually doing the experiment, because doing the experiment's hard. From Hercules with the $5, teleport potable water to people who don't have access to it here on Earth would solve a lot of problems. The thing is quantum teleportation is not moving matter from place A to place B. It's just changing the matter at place B so that it matches the matter at place A. But you're not changing like the chemical composition or anything. You're changing the quantum state. So like you can teleport like a spin up. You can take a spin up particle and then quantum teleport it so that there's another particle that doesn't have an assigned spin over there that grabs the spin up from the one at point A and becomes the spin up at point B. And from Butch Bauman with the $5, when the orb was hit by a hellfire and broke apart, why did the fragments keep moving with the main orb instead of scattering? I don't know. Is the singularity a physical reality? I suspect not. Do you have any outside-the-box theories you were working on? I mean, yeah. They're kind of like, I have a few ideas that are kind of rattling around in the back of my head. Those are the fun things to think about, but they're nothing that's concrete yet. Does wormhole exist? Almost certainly not. What Newton did wasn't just derive that law, but prove things about it using calculus. Well, I'm aware of that. I just don't know how he actually came to that law in the first place. I don't know the history there. Thoughts on the Green brothers? I like them. I think that generally they're a force for good in the world. I think that they do a good job. At least Hank Green does a good job, an excellent job teaching science. His enterprises are generally like, as far as capitalism can be good, I think that they're solidly on the good side of enterprise. I think that generally they're good. And John Green is a very talented author. I think that he's done a lot of good work regarding tuberculosis. Why doesn't the asteroid belt coalesce into a single body? I just don't think it has enough gravity to do that. Like, there's just not a lot of mass in the asteroid belt. Parallax is the reason the balloon kept moving when hit. Yeah, I haven't seen the video. I haven't I've seen like clips of it. I don't know, I haven't analyzed it or anything like that. I don't know how far away it is or what else we can say about it. If you're a physicist, why do you work at Subway? I don't work at Subway. How many digits of pi do you have memorized? Let's see, 3.1415925. So 8 digits of pi. What's your specialty? What was your PhD about? So my specialty is in differential geometry and general relativity. Not going to tell you what my PhD is about because apparently that can dox me, but that's the kind of thing that I do. I specifically focus on conformal geometry and on some cosmological implications of general relativity. You have videos on your account of you in your Subway outfit? No, I don't. I mean, but if people don't believe me, they can go look at my account and scroll. They won't find any. Can you please explain Einstein equation E equals mc squared? Yeah, so all that equation is saying is that there is an amount of energy that that a certain amount of mass at rest is equivalent to a certain amount of energy. And what that really means is that if something emits energy, if it emits a photon with a certain amount of energy, and it was at rest, then its mass must necessarily decrease by the amount given by E equals mc squared. Are the equations in general relativity usually analytically solvable? Very, very rarely. Why do particles other than light behave like waves? Because everything is waves. Dr. Blitz, can you please explain what a wave is? Yeah, so a wave is a disturbance in a medium, right? It's a disturbance in some underlying thing. So think of water wave. Typically, the medium, water, is just placid. It's just like, you know, nice and calm. But if you disturb it, then you'll get some sort of thing. And that disturbance, essentially because of the physics that guides the way that media move, that disturbance will propagate. It will move. Carlo Rovelli suggests that particles may not actually have any physical substance to them. Legit? I mean, there's some philosophical questions there. Maybe it's legit. That gets deeper than the actual physics, though. But generally, Carlo Rovelli is pretty highly regarded, if you will. How is the photon its own antiparticle? On my knees begging? Well, so in order for one of the ways that you can form an antiparticle, or one of the ways that you can check if something is an antiparticle, is can you combine the two things and then make them spit out two photons? And then of course you can do that with two photons. But really, I mean, the thing is in order for a thing to be its own antiparticle, it must have zero charge of any kind, and photons have zero charge of any kind. Because all of the charges are the negative of, like, all of its charges are the negative of themselves. That's what zero means. Do photons have subphoton particles just like atoms, or are they just one singular thing? Photons are the smallest chunk of electromagnetic waves that you can get. So they're not made of something smaller. What kind of physicist are you? So I'm a mathematical physicist, which means that I am half mathematician, half physicist. And so if I go to a mathematics conference, people will think I'm a physicist, but I act like a mathematician. If I go to a physics conference, people will think I'm a mathematician, but I act like a physicist. So yeah, it's somewhere between the two. Element 115, who invented it? Well, I think that there was a collider in Russia, I think. It's called Moscovium. It was discovered, yeah, in Dubna, Russia. Yeah, in 2003. So yeah, it was headed by Russian nuclear physicist Yuri Oganessian. Was the discoverer, if you will. Why don't two parallel lines converge at a distance of even 1 million trillion light years? Well, it depends on, like, if you're in Euclidean geometry, by definition, parallel lines don't converge. But if you're in some other geometry, then they can converge. If E equals mc squared, how does light have energy? That's not the full formula. That's only the full formula for things that are not moving. But photons are moving. The full formula really is E squared equals mc squared plus pc squared. And p there is momentum, and photons definitely have momentum. The element is said to power exotic propulsion. The element does not do that. We've made it. It doesn't do that. Can you explain why space expands between galaxies, but galaxies still hold together? Essentially, gravity. You can basically ask, so you can think of dark energy as just some material that has negative gravity. And if it has negative gravity, you can just say, well, in a given region, like a solar system or a galaxy or whatever, in a given region, is there enough negative gravity dark energy to overcome the attractive regular gravity from the mass? And the answer is no. It's only in places where there's not a lot of mass and that mass is very far away that the negative gravity is strong enough to push stuff apart. From Daniel Rathbun with the $2. Important question, favorite Pokemon? I had a Charmander, or a Charmander rather. I had Pokemon Red when it first came out. That's probably my favorite, maybe. I also like Bulbasaur though. From KCJ Bomber FTW with the $10. Physmathician. If you spin a black hole to create a donut, could it cause space cavitations? Well, the black hole will never become a donut. There's something called an extremal black hole, which is essentially the point where the event horizon disappears and you end up with a naked singularity. But you can't spin it faster than that, so you would never form a donut. All that happens is as you spin it up, the event horizon kind of shrinks and shrinks and shrinks and shrinks. But you never end up with a donut. So but regardless, I don't know what you mean by cavitations. Doesn't the E equals mc squared mean everything, the mass is concentrated energy? Well, neither energy nor mass are substances, but again, please don't spam. I will mute you for a time if you do. Why would the singularity not be a physical reality? Singularities are, at least historically, singularities are, when singularities pop up in your mathematics, that's a sign that your physical theory is breaking down. So if you took classical electromagnetism seriously, then that would mean that there would be places where the electric field is infinite. But that was really a signal that classical electromagnetism just doesn't hold up. And instead, once you incorporate quantum electromagnetism or quantum electrodynamics, then the singularities disappear. Briefly explain why entropy always increases. Well, so the thing is that it doesn't, like that's kind of like an observational fact. The way to think about this is that if you imagine randomly shuffling something every moment of time, then the system will end up in the kind of in the higher entropy state just statistically. But the question is why is it that it started in a lower entropy state and shaking it would increase, shaking it gets you to the more common higher entropy state? And that's kind of just an initial condition that our universe seems to have had, that our universe started, if the universe started at all, then it started in a low entropy state. How do you reverse Earth's gravitational pull? I don't think you can. If light was 2x faster, would life exist? Sure. Everything would just seem twice as small, right? Do you believe that frame dragging could be used to create closed loops of time? Yes, it can be, but you either need an infinitely large rotating cylinder called a Tipler cylinder to make that happen, or you need to be inside a rotating black hole. Can randomness ever truly exist, or is it just complexity we don't understand? In principle, randomness can truly exist. There are some interpretations of quantum mechanics that have true randomness. Why do people keep comparing me to pirate software? I don't know who this guy is. I just know people don't like him for reasons that I don't understand. How does superfluid helium do all its crazy stuff? Because it's a superfluid, and that's what it does. Have you ever read any books by the sci-fi author Greg Bear? No, I haven't. If the universe has no edge, how can expansion be understood without space outside it to expand into? So expansion is a local thing. Expansion is what happens to space itself, not what happens at the edge. So just think that there's more space in a certain region than there was before. When's the next unapologetic show? It's every Sunday. God, I have like this thing in my throat. I don't know if I'm getting sick or what, but okay, I have a dumb question. How do we know the universe is expanding? Well, that's the common interpretation of the data that we have. Essentially, if you look in any direction, everything except the closest things seem to be moving further away from us. And the further away you look, the faster they seem to be moving. Now, what this could mean is that like for some reason we're the center of the universe and there's just like an explosion of stuff for whatever reason. But a better explanation is merely that the universe is expanding, and that would account for the fact that things further away are moving away from us faster. What even is frame dragging? Frame dragging is the phenomenon where space essentially gets twisted around something that's rotating quickly that has a lot of mass. What's going on with that planet James Webb found and conclude that we miscalculated its distance? I'm not familiar with the question. Okay, so KCJ Bomber with the $10 explains, Pirate Software was a pale glasses wearing genius hacker for the government WoW game designer. Okay, so it's just because I'm pale and wear glasses? Okay, I guess. Aren't all your beliefs based off of the uniformity of nature? Yeah, I guess. Well, I suppose not all of them. Some of my beliefs are like mathematical, but could Hawking radiation be time, broken into its simplest form but rejected by timeless place? I don't know what that means. I don't know what that would mean. Could time crystallize or behave differently at very small scales? In principle, yes. But again, we don't really have any evidence that supports this. How would a black hole dissipate? Would it expel a bunch of energy? Yeah, so that's what Hawking's prediction is. That yeah, absolutely it does. Why is the speed of light c? Well, that's just the letter we use. I don't know why that's probably c for constant is my guess. What would happen if photons gained mass but retained speed? Then you'd have to violate relativity. Did you ever consider that the universe might be under different laws of physics? different from the current ones, well then that would just mean that we're wrong, which I guess we could be. It'd be weird though. Can the arrow of time reverse locally in rare conditions? Yeah, in principle, sure. The second law of thermodynamics is a statistical fact, meaning that it just happens the vast majority of the time. And if you say that the arrow of time is merely the direction in which entropy increases, then yeah, you could have it reverse, I suppose. Why is Zeno's paradox false? Because Zeno didn't understand that you can have that traveling an infinitesimal distance would take an infinitesimal amount of time, and you can add up an infinite number of infinitesimal things, and if you do that, you will get a finite answer. Zeno's paradox was essentially resolved by calculus. Did Hawking visit Epstein Island to explore black holes further? My understanding is that Epstein used to host scientific conferences, because Epstein, like most bad people, they weren't bad, and Epstein probably wasn't a bad person in his entirety. I'm sure he liked science, and so he, being a rich person, hosted science stuff. He also abused children, and that's like, it's unfortunate that somebody who probably did good things for science was also like a shit human being otherwise. But that's like I mean, like, Hitler was a vegetarian, right? Like, sometimes bad people still do good things. From Super Pizza with the $5, what would bare atomic nuclei look like to the human eye? Like if you turn down the brightness of a neutron star? That's a good question. Well, in order to see them, they'd have to either reflect light or give off light. And the thing is nuclei, the energy levels so the reason why we can see things in the first place is because atoms, the electrons around atoms have different energy levels that correspond to visible light. However, nuclei, on the other hand, do not. The energy levels in nuclei, if you were to change the energy level of a nucleon, which is the particle that makes up a nucleus, those energy levels are like deep into the X-ray and gamma ray parts of the electromagnetic spectrum, and so you just wouldn't be able to see it. So I guess it would look black. Well, actually, I guess that they would also, yeah. Like a bare nucleus is smaller than a wavelength of light, right? All right, with 5 British pounds from AC 86, if it was possible to extend an unbreakable rope between the event horizon of 2 black holes, center equidistant from both, what would happen? The thing is once you instantiate unbreakable things, you're violating relativity already. Relativity actually puts bounds on what it means for something to be unbreakable or unstretchable or whatever. So it's just not a question that I can answer within the bounds of relativity, because relativity precludes the possibility of such things existing. And from Fear's interaction with the $10, no question today, but Blitz is about as far from pirate software as I can imagine. The packaging is superficially similar at best. W Blitz, stay hydrated. Well, thank you. I appreciate that, I guess. If Hawking radiation is particle-antiparticle pairs, why is it always the anti that goes into the black hole? That's not what's happening. So in the particle-antiparticle pair analogy, and by the way, that's not like what's actually happening, but it's an analogy. What happens is that one of the particles, not the particle or antiparticle, but just one of the particles has positive energy and the other one has negative energy. And the point is that the one or rather, you end up with a particle-antiparticle pair at the event horizon. And the one that's on one side of the event horizon, by definition, has negative energy. And the one that's on the other side of the event horizon, the outside, has positive energy. And so the point is that by being inside the event horizon, the particle that you create automatically has negative energy. And so it falls in and that energy subtracts from the mass of the black hole. It doesn't have anything to do with whether it's a particle or an antiparticle. From Daniel Rathbun again with the $5. Thank you for being so generous. I appreciate it. Are there any current science experiments going on that you're excited to see the results of, like maybe stuff coming out of CERN? Nothing that I'm really closely following. Yeah, I mean, so LIGO's really important, but we've seen a lot of the important results there already. I mean, there's a proposal for LISA, the laser interferometry space antenna, which is essentially a gravitational wave detector that's supposed to be in space. And that's going to be launched in the 2030s. So I'm really excited for that, because then we'll get a whole lot of new data. But nothing that's existing right now I'm really super anticipatory for. Quantonaut, I know that there's the electron ion collider, but there's just like, I mean, look, if something amazing is detected, like, supersymmetry or dark matter, then that'd be great, but I'm not like anticipating something in particular. In your learned opinion, what do you think Oumuamua was? A comet or asteroid kind of thing. Basically a rock. When are you going to get bit by a spider and change? That's a good question. I'd rather not get bit by a spider. Is the universe expanding non-existence, or is the universe expanding to existence? I don't know what that question means. Should flat earthers be allowed to vote? Everyone should be allowed to vote, but we should have better education. If the universe is expanding, does the mass of the universe being gained or subtracted? So it depends. So in some sense, the mass of the universe, if you include the total energy of the universe, is increasing, at least of the observable universe, say, because there's more dark energy. And dark energy has energy, which therefore has a mass equivalent. But like the actual matter in the universe is staying the same. Why is it that the universe expanding causes energy to not be conserved? It's more that it doesn't allow us to define total energy or define a global energy density. The way that you define a global energy density is that you need something called a time-like killing vector in your space-time. And what that essentially means is that the universe must be static. And because the universe isn't static, because it's expanding, because it's changing, you just can't define a time-like killing vector. And so any way that you would want to define energy is necessarily going to be kind of position dependent, or it's sort of reference frame dependent. Which means that any energy that you come up with is purely subjective, basically. From Sean with the $5 says, talk about Townsend Brown testing the bifield Brown effect, the Zerk point energy. I've never heard of any of that. Do you think Avit Loeb is bugging? Maybe. Please explain particle spin to me like I'm a toddler. Yeah, so it's like a ball that's spinning, except it's not a ball and it's not spinning. African or European swallow? A great question. Do observer effects really exist, or are they just misinterpretations? Almost certainly, at least in my view, they are misinterpretations. Are the small structures just too small to have gravitational effects, and that explains incompatibility? I don't know what the question's really about. Could it be that the universe isn't expanding but matter is just attracted to the borders? I suppose that you could say that. Would that be consistent with all of our observational data? Yeah, but it can't be a gravitational attraction. It has to be something else, because the gravitational force would say that matter at the borders wouldn't have a gravitational effect on the interior, or at least not an attractive gravitational effect on the interior. I thought physics was dead. Can't ChatGPT just do it? From experience, no, it cannot. Are we experiencing time at its true speed, or does our brain slow it down? I don't know if it makes sense to talk about a true speed of time. If the multiverse exists, could realistic Peter Griffin exist? I guess, but there might even be a guy that's like that on Earth. How good is physics for getting into quant? I have no idea. Who's your favorite physicist? It has to be Albert Einstein, right? Is the universe expanding to non-existence, or is the universe expanding to existence? I don't think that, like, I don't understand what that sentence means. Like, the universe is expanding. Existence isn't a place, right? Are you suggesting that coconuts migrate? They do. Coconuts do migrate, yeah. I know that the swallow comment was a movie reference. I'm aware. I'm very aware. Advice for getting through a physics PhD: find an advisor that you actually like personally, that you get along with, because you're going to be spending a lot of time with them. Why do you like math so much? Because it's objective, right? In some sense. How do massless photons have momentum? Better question is, why do you assume things have to have mass to have momentum? It occurred to me you were a physicist, but also a polymath. I don't know if I would call myself a polymath. Do you think Mabwas Industries' plasma engine is possible? I doubt it. But I haven't looked into it, so maybe he's onto something. But, you know, generally, the general rule of thumb is if somebody thinks that they're doing something groundbreaking that requires, like, super advanced physics, and they don't have a physics degree, then they're probably not doing that. Instead, they're probably trying to sell you something. What are some potential things that could cancel out a high energy contributions in the standard model? Well, supersymmetry was hoped to be one of them. Gravitational or space-time fluctuations is another that I worked out. I and a few other people have worked out or worked on. I don't know what else. I don't know what else it could be. Maybe some particles that we don't know exist. Thoughts on Reed Richards in Fantastic Four First Steps? I thought it was a good movie. I liked it. It was a little bit like baby propaganda, but eh. Is the expansion of the universe faster than the speed of light? It's not. It's kind of a category error to talk about how fast it is. The expansion of the universe is a rate, meaning it's something like it's a doubling time. So the universe is doubling in size every 10 billion light years or so. Thoughts on eternal return? Sorry, of philosophy. Eternal return is similar to the idea of a cyclic universe, right? So I think that it's at least plausible. I think so. Anyway, thank you for the $2 Nectu, as always. What about the Great Attractor? Does this just prove how little we can actually see? So the Great Attractor is almost certainly just more galaxies. But the trouble is that we are inside a galaxy which has lots of dust and lots of stars. And so if you look in specific directions in our galaxy, there's just stuff in the way. So you can't see stuff on the other side of the galaxy. So the Great Attractor is almost certainly just more stuff that we just can't see because our galaxy is blocking it. It's probably very uninteresting. From KCJ Bomber with the $5, thank you again. Why do mock rings matter? What's a mock ring? I don't know what a... Oh, so these are shock diamonds. I don't actually understand them particularly well. I don't know why you would call them mock rings, but yeah, I don't really understand. Like, something that I'm not particularly well versed on is fluid mechanics, fluid dynamics, because it's really complicated. And it's just not taught. Like, it used to, fluid dynamics, like hydrodynamics and all this stuff, used to be super commonly taught in undergrad and in grad school. Like, it used to be a super important part of physics education. It's just not as much anymore, for reasons that I probably don't understand, but Are black hole interiors physically real or holographic constructs? It seems like you should be able to go inside a black hole. It doesn't seem like there shouldn't be like some physically real place that you can go. I don't know what it would mean for it to not be physically real. At least if we treat space-time classically, it's just another region of space-time, right? Is there a reason the universe has many empty spaces which would be unlikely if purely statistical? No, it's actually kind of expected, right? Because gravity causes things to clump up. And so if you have clumps, then that means that you also must have voids. Do you know Rassi Talon? We're mutuals. We haven't spoken in a while, but I know that he does astronomy or astrophotography, which is kind of neat. How old are you? I'm 32. Black hole era and super distant future, cool or scary to you? Well, who knows if it's actually will be the case, but I think it's cool. Do we already know everything there is to know about fluid dynamics? I suspect not, but I suspect most of the problems are pretty applied, with the exception of solving the Navier-Stokes equation, but that's more of a mathematical problem. Just popped in, what's the most intensive math course you've ever taken? It was physics, and it was topological quantum field theory. I still don't understand it. Do you prefer GIFs on TikTok or Super Chats on YouTube? So Super Chats on YouTube take a little bit less money. GIFs on TikTok take like 40% or 50% or something. YouTube takes like 30%. Cash App is better in general because Cash App takes none. But, I'm not picky. Larry Beck, thank you for the $5. I appreciate you. Thanks so much. Would you ever do a second PhD? And if so, on what? There was a time when I was a kid and a teenager where I'm like, I'm going to do 2 PhDs. I'm going to do a PhD in math and a PhD in physics. The thing is I've realized I don't need to. Like, you don't need 2 PhDs. It doesn't really help you. The whole reason why you do a PhD is to learn how to do research. And then you do research, and then you're given a PhD. But why would I do it twice when I can just do the mathematics research now? Like, I learned how to do research. Like, I know how to do research now. Like, I'm published, over a dozen times. So why do it again? It wouldn't add anything. I wouldn't learn anything. How much do you owe for your PhD? 0. STEM PhDs in the US, you don't pay anything. Can you explain superposition? Yeah, so the best way to explain it is just to think about classical waves. So anytime you have two waves, they can add together on top of each other, and then they're in superposition. So think about playing a chord on a guitar. So the sound wave that's produced is a superposition of all of the individual notes that you play on the guitar. Are you assistant professor? No, I'm not a professor at a university. I'm an associate researcher at a university. I have like an affiliate position. I'm applying for more postdocs this cycle. Maybe I'll apply for some tenure track positions as well. Do you know what is a Hilbert space? Yeah, Hilbert space is a type of vector space with an inner product. It has to be complete. There's a few other requirements. I always end up looking them up just so I don't miss anything. Did you get a master's before doing your PhD? So most STEM PhDs in the US go straight from undergrad. So you start from undergrad, you apply for a PhD program, and then along the way you get your master's. After you finish your classes and after you pass your qualification exams, you get your master's degree and then you ascend to candidacy. So that's usually 1 or 2 years. You don't pay anything for STEM PhDs in the US, right? You get a stipend. Yeah, STEM PhDs are in some sense a job. Yeah, you're teaching or doing research or something like that. Does EM ray have a minimum wavelength can't be smaller than a high energy gamma ray? So I actually have a video on this coming out soon. In practice, there are in a sense upper limits, because then you can just basically have light interacting with other light. The photons interact with other photons that will sap energy. Also, in principle, you can't have a photon, at least we suspect that you can't have a photon with a wavelength shorter than the Planck length, because if you did, then it would essentially create a small black hole or something like that. So in sort of there is like a shortest or a highest possible frequency, shortest possible wavelength. Yeah. Yeah, Hilbert spaces are complete with respect to a metric, but the metric doesn't necessarily induce a norm. I thought that Hilbert spaces have inner product, and the Hilbert space gets, or an inner product always induces a norm, or maybe that's only on finite dimensional vector spaces. Yeah, so so they're a complete. Oh, okay, yeah. So they're a complete metric space, but the metric isn't necessarily the same that you get from the inner product, I guess, right? Oh no, I'm sorry. They're complete metric spaces with respect to the metric induced by the inner product. Yeah. So, but maybe I guess the point is that you can have vectors with infinite norm, so you don't necessarily get like a finite norm, I guess is the point that you're saying. Have you ever done a collab with Jorge Physics here on TikTok? Yeah, we used to interact a lot. I don't really do that kind of, like I haven't done that, we haven't in a while, but yeah, we're mutuals. Bet $100 he's Jewish. Well, I am, yeah, good guess. Weird thing to bet though, but you owe me $100 now. If the universe is spatially infinite, would that mean that it always has been, even at the moment it began to expand? Yeah, yes. How can you be a physicist and not acknowledge telepathy and remote viewing? Well, I'm not convinced that the evidence is is like sufficiently compelling to do that, to like be able to make that kind of claim. Tips for my kinematic test tomorrow. Oh, tips for that? It might be too soon, but do a lot of practice problems, I guess. From Connor Carter with the $5. What do you think the universe would be like if the fundamental forces didn't care about distance, i.e. gravity pulls the same at 5 meters as it does at 5 miles? Oh, everything would be different. I don't even know if we'd have a universe. Mrs. Dr. Blitz wants to say hi. She's leaving, so everybody say bye. Right. A small hint of Dr. Blitzler right there. Indeed. Oh, no, never mind. Does expansion add spacetime or just thin it out? There's not really a way to distinguish between those, right? What would happen if water traction didn't exist? I don't know what you mean by water traction. How much was your stipend? They're giving me 25K in HTX for CogSci. Yeah, so sorry, I have to close the door. Yeah, so my stipend, so to be clear, I got my PhD in 2022. So, and I was a teaching assistant as a PhD student for two-ish, or for 2 years of my master's and then 2 years after that as a PhD candidate. And then I got paid like $23K or something like that. After my first few years of being a teaching assistant, they had me be an associate instructor, which means I had my own lectures. I wrote my own exams and things like this for, 180 engineering students. Then my stipend went up to like, depending on if I taught in the summer, like 29 to 32K a year. But it wasn't very much. Now, this was in California. California recently got a huge pay bump because they basically protested and unionized and all of this stuff. So they make significantly more now than I did. I think they make like 35K a year just as a TA. But, PhD students are not paid particularly well. Can you explain how electricity goes through a wire? Isn't it electrons flowing? So it is electrons flowing, and it's also electromagnetic fields propagating. Was the nothing before the Big Bang truly nothing? We don't know if there was nothing before the Big Bang. 32K a year, isn't it too small? Yes, it is. You do not. It is like extreme poverty. Yes. Now keep in mind this was, right after COVID. Like this was 2019 through 2022. But yeah, it is extremely low. Like, and this was in California. So like the stipend was very, very low. Stipend for US nationals only? No, not necessarily. If you get accepted into a PhD program, you're going to get a stipend in the US. In STEM. If energy can't be destroyed, where's your equation for the soul? I don't think that souls exist. How am I on more than that? I'm a bricklayer who all of a sudden feels better about my job. Yeah, so look, the thing is what they say, and this is just me ranting a little bit, but what they say is essentially, oh, well, your stipend is actually on top of the tuition waiver that you get, right? So they'll be like, oh, well, we're actually waiving 45K of tuition, and then we're giving you 25K on top of that as a stipend. So really, we're giving you 70K in value. But realistically, they're not teaching you classes, right? So that's what they say. That's how in principle they justify it, because your tuition waiver. So they're not paying less than minimum wage, right? But scientists fear acknowledging decades of potentializing disinformation. I don't know what that question means. What is your IQ if you've had it tested? I don't know. I think my mom had it tested when I was a kid, but she never told me, and it's probably a good thing that she didn't. Okay, we have anti-Semites in the comments. Cool, let's get rid of them. Why is it that when fluids move, their static pressure decreases? Oh, that's an interesting question. Yeah, so is there actually a good, what's the good intuition for this? I haven't thought about it in a while, so I'd have to think about it some. So I guess the point is, yeah, essentially, why does it push on so maybe one way to think about this is that if the velocity of the particles that make up the fluid, if the kinetic energy is sufficiently high, then essentially, because perhaps one way to think about it is that if the velocity is high in one direction, you essentially, in order to have the same pressure, you have to have more velocity in the other directions to push on the walls, because otherwise the velocity is negligible compared to the velocity in the other direction. So most of your energy, most of your momentum will be in the direction of motion. That's perhaps one way to think about it, but I'd have to think about it a little bit more. Connor Carter with the $2. Do positrons plus electrons violate matter destruction? Well, yeah, but the law of conservation of matter is just not a law. It's just not. It's a law in chemistry, I suppose. Did you have to pay taxes on the tuition they credited to you? I didn't for my neuroscience PhD, but not sure how other institutions handle it. I didn't have to, no. Is everything a field currently the latest model of physics? Yeah, sort of, but that's not so new. That's maybe 50 years old. Explain the right-hand rule in electromagnetism. So the right-hand rule is just how you do cross products. So anytime you have a cross product, you can have a right-hand rule to tell you what the direction a vector is in. So for example, if you have a vector that points in one direction, the direction that my hand's pointing in, and another vector that you cross it with that points in this direction, then my thumb points in the direction of the resulting vector. And so because cross products show up a lot in electromagnetism, you can see that it would be relevant. For example, you can see that if you curl your hand in the direction of rotating current, then that'll give you the direction of magnetic field. And that follows because it's what? It's I cross L is the, sorry, not I cross L. What is it? R cross L. Or maybe I got the sign wrong. The Biot-Savart law tells you what direction the magnetic field is for a current moving through a wire. And so if you have R cross L, so it's R cross L. R is the direction from your point to the point of current. Then you have a current. So if R is pointing this way, L is pointing this way, then if it's going around in a circle, then your current will move, or your magnetic field will point upward. Anyway, that's how it's used. How do you write research papers and how do you publish them? Well, writing them is basically coming up with an idea, and then working out the details and showing that it makes a good point, or that it solves a problem, or that it makes an interesting prediction. Now, the actual work of writing the research paper is kind of hard because you have to make sure that it's novel. It has to be an original idea, and that's coming up with original ideas these days is hard. And it has to be correct, right? Like it'll be rejected if if you did something wrong. So. And then publishing is just a matter of basically going to the journal's website and then submitting. There will be rules for submission. There will be a form that you fill in, something that you upload. Are you a professor? No. So professor is an academic title. It's a title granted to professors at universities and other academic institutions. I am a doctor. I have a PhD in physics, a doctorate in physics. Is Boltzmann's brane theory realistic? Its implications are very concerning. So it depends. It depends on the theory, right? So generally, the view is that Boltzmann branes are cognitively unstable, meaning that if you have a theory that you think would lead you to conclude that you are more likely to be a Boltzmann brane, then that means that your theory can't really be well-founded because it would be based on observations that are not actually real. So almost certainly Boltzmann branes are not a real thing, and you shouldn't believe any theory that leads you to the conclusion that you are more likely to be a Boltzmann brane. However, this is you should sort of treat this as like a filter for theories. If a theory would lead you to conclude that you're a Boltzmann brane, you should throw the theory away. That's a way of thinking about it. So do you want to be a professor? What do you want to do with your PhD? Yeah, so I'm applying for positions. I'm currently applying for more postdocs, so I might apply for some professorship positions. Did you always get straight A's in school? Did you know you're always this smart? I did get straight A's in school. I got my first A- in grad school in statistical mechanics. Make of that what you will. How do you find peers to review your work? How does that work? You don't have to find the peers to review your work. You submit it to a journal. The journal will reach out and find the referees for your work. Apply to Vanderbilt? I'm going to. I actually think that that's on my list of places to apply to. I have a big long list. I think Vanderbilt is hiring? No, they're not on my list yet, but I have to check. There's a few places that you can check. But yeah, there's a lot of places that I'm applying to right now, or that I will be applying to soon. Not literally this moment. I'll probably work on some applications today, actually. Would it be possible to publish a paper as an amateur astronomer or amateur detection of velocity aberration from Earth's orbit, or would the lack of novelty just get it rejected everywhere? Well, so if it's not novel, then it's probably not worth publishing. But if you have like a new updated measurement of something that is like increasing precision, that might be worth publishing. If light experiences no time and relativity has no absolute frame, is there a sense in which all things happen or are happening at the same time? Light doesn't experience no time. Connor, thank you for the $5, by the way. Light experiences affine time. It doesn't experience proper time, so it doesn't have a watch. But there is a sense in which there's a before and after for light waves. It's called affine time. Do journals reach out to you to review? Yes. In fact, I have one sitting in my inbox that I probably have to accept. I should probably accept this revision or this referee because I haven't done any referee work in I haven't done any referee work in a while, and it's probably worth doing because this is a paper that I probably have something valuable to say about. How do we become a physicist if I'm dumb? Well, being a physicist is in some sense a smart person's game. Like, I'm not gonna sugarcoat it. Like, being a physicist, it's an intellectual job, meaning that you have to, be capable of having original thoughts and critically thinking and thinking quickly and things like that. But I would be hesitant to say that this is something that like requires an above average IQ. Like, you'll probably have a hard time if you have, like, if you struggled in school the whole time. But like, if you're like a normal person, I imagine that with sufficient work you could get there. What is the cause of the Pauli exclusion principle? That's an interesting question, because in some sense it's like a physical law, and we generally don't think of physical laws as having causes, but you can kind of, if you treat it as like a consequence of something more fundamental, then you can kind of come to that conclusion. So you can treat it as a consequence of like the spin statistics theorem, which says, well, you know, you get certain, if something has certain spin, then it must have certain statistics, but that's kind of just another way of writing the Pauli exclusion principle. So it's not... It's probably best understood as like, this is a fact of our universe, and maybe it's not something that we know about what the cause would be. How does the math break down as we get closer to the singularity of the universe? So the point is that so a singularity is only a problem when it becomes, when it's referring to a singularity, something becoming infinity, on something that you could in principle measure. So in principle, you can measure space-time curvature. You can have like a gauge or like a detector that measures space-time curvature. And if the space-time curvature at the place you're trying to measure is infinity, that's a problem, because you can't measure infinity. Infinity is not a number. So because the space-time curvature near the original singularity of the Big Bang is infinite, that's how kind of why we expect it to not be a real thing. Did you find the show Big Bang Theory entertaining or annoying? I thought it was generally entertaining as far as sitcoms go. If inflation explains cosmic smoothness, what physical mechanism actually drove it? So there's, I mean, the idea of inflation, there's kind of like the commonly accepted idea nowadays is called slow roll inflation, where basically you have something akin to dark energy at the very, like, that's extraordinarily high energy. Right now, dark energy is very, very weak. But there's something akin to dark energy that's extraordinarily high energy in the very early universe, which is driving very, very rapid expansion. And then it's somehow, via quantum tunneling or via slow rolling or whatever, you have a decay to a lower energy state, which dumps its energy into the other particle fields. That's the rough idea. What would happen if I fall into a black hole without charge? Well, eventually you'd probably die. Whether it has charge or not would be a bad time. Please explain supersymmetry. Supersymmetry is, as far as the physics idea goes, supersymmetry is essentially just the idea that every particle has a supersymmetric partner, which just means that if you have a particle that has a half integer spin, then that means that it has a partner that has a whole integer spin. So you would have a squark. Quarks have half integer spin. A squark would have a whole integer spin. And I guess that they would be gauge bosons, or they would be bosons. So I guess a squark is spin 1, right? No, sorry, they're spin 0. They're scalar bosons. So yeah, I mean, it's just a theory that like every particle has a supersymmetric partner, which just says that like the number of fermions and the number of bosons kind of balance out. But we haven't detected it. Is squark a word I can use in Scrabble? I guess. At least you should be able to. If two different proofs exist for the same theorem, is one more true than the other? I wouldn't say so, no. Do you have photographic memory? I don't think so. I mean, I do have a fairly good memory for texts that I read, and the way that I remember it is by thinking about where I saw it on the page, the way that I can find it. So perhaps a limited one, but not particularly. I have generally a bad memory, but like the way that I remember things is often kind of in a photographic sense, if that makes sense. Is the future already written, or is it created anew every moment according to our decisions? It depends on your preferred interpretation of time, but the way I think is that it's already written. Is it possible for black holes to be so low density that it messes with their event horizon? No, in principle, you could just have an enormous black hole that would just have a low density, but its event horizon would still be an event horizon. I don't have any money for a PhD, so can I get an engineering degree then go back for physics? So STEM PhDs, at least in the US, don't cost you anything. In theory, could cosmic inflation lead to multiple universes with different physical constants? In principle, yes. This is something that people have thought about. If string theory is right, is it just energy and vibration that dictates what it is? I wouldn't say that it's the vibrational. It would be the vibrational state, yeah. Did you get your PhD in the US? Yes. Can you explain affine time a little? I'm having trouble understanding how light and relativity interact. Yeah, so affine time is a way of parametrizing a a trajectory. And so you can have, the trouble is that it doesn't give you durations, it only gives you befores and afters. Because there's an arbitrary rescaling that you can do, and an arbitrary shift that you can do. So it doesn't make sense to say that this much affine time has passed for a photon, but it does make sense to say that this event took place before that event with regards to affine time. You can just think of affine time as just as a generalization of the notion of proper time, which is what watches do. What jobs can you get with a BA in physics? I have no idea. Oh, somebody, did I get I got a Cash App. I should read the Cash App. From Aaron, thank you for the $10 for You Rock. I appreciate you. And I got, and I got a €15 super chat from Tesseract. I don't know why that didn't pop up, but thank you. Appreciate you a lot. Is the wave of a photon continuous from its origin? Sure. I have a BSc in physics, but ended up in banking. Yeah, I believe that. Would it then be possible for an organism to be made of symmetrical particles? Do you mean like the supersymmetry stuff? I suppose, yeah. Stop taking meth, slow down your speech, speaking fast doesn't mean anything. This is how fast I talk. If you don't like it, you can go watch in slow-mo version on YouTube. If you do a PhD in the US, can you do a postdoc outside the US? That's what I did. I got my PhD in the US, I went and did a postdoc in Europe, now I'm looking for postdocs back in the US for family reasons. Realistic QFT is just dastardly, oh, no, that's not a question. What's your best theory on how the universe will end? I'm pretty agnostic about it. Like at this, there was a time a few years ago when I would have said it will end in a heat death, but at this point, I'm very agnostic because the evidence is different. Do you pay your mods? No, I don't. They do it, they volunteer. I guess because they would be watching anyway and they don't like spam, so I don't think I make enough money to pay my mods. I make like, for full transparency, on YouTube, I make around $1,100 a month. On TikTok, I make significantly more, but even from my income from TikTok is 90% from the videos that I make, and then maybe about 10% from the live streams. So no. No, I don't. If it was a full-time job, then I might, but it's not a full-time job for me either, so. How many dimensions do you think exist? 4? 3 of space, 1 of time? Is it necessary that the average student can't be a great physicist? Is it necessary that the average student can't be a great physicist? Well, if you're average, then I think that kind of by definition, you're not great, right? What kind of physicist are you? I'm a mathematical physicist, which means I'm like half mathematician. Could spin be thought of as the magnetic field of a point charge orbiting the center of a particle? No, because if it were, then that means that there would be substructure for these fundamental particles, but the fundamental particles, as far as we can tell, don't have substructure. Can you explain PN junction diodes? Not well. I'd have to go refresh. There was a time when I could, when I was really into semiconductors and like electronics and stuff, but I haven't thought about it in a long time. Is it possible for anything other than time to exist inside the time dimension, but not in space? Well, no. I mean, the point is that when we say that something exists, we say that it exists in space-time. So it can't be only in time and not in space. Are you aware of Gödel's incompleteness theorem? I am. I actually used to live in the city that he was born in. And I saw the house that he was born in. I actually made a video about him in front of that house. Or about the incompleteness theorems, rather. Actually, no, it wasn't about the incompleteness theorems. It was about the Gödel universe, which was a general relativity thing that he also did. I'm a recent graduate student with an astrophysics bachelor's. I was wondering how someone works towards publishing papers and what the hierarchy of researchers is, including people who lead papers. So it depends. In all of my experience writing papers, which isn't a lot, bear in mind, I have like a bit more than a dozen papers to my name. In all of my experience reading papers, or writing papers, we just put names in alphabetical order. Now, I know that in labs, often the ordering of names matters, and so a first author paper is like an important thing. and you would say that like the PI is like the most important, the person who did the most work and things like this. So that's a thing. I don't really know how it works though in like the lab setting because I've never been in that setting. I'm a theorist, so yeah. I mean, so about half of my papers are math papers, which is why that's the case. The other half are theory papers, yeah, we've just done alphabetical. Maybe that's not the norm. But there's only one paper where I haven't been a significant contributor to that I've written. And so I don't know. But I wouldn't want anyone to feel like left out. Anyway, why are you so loud? My mic is kind of finicky sometimes. What kind of math research are you working on right now? Well, I'm working on a paper. I started writing a paper on Thursday or on Wednesday or something, trying to prove the non-existence of a particular type of conformal invariant, which, you know, my paper is actually almost done. It's a short paper. It's just a quick non-existence proof for something that's been bothering me for a few years. So that's something I'm working on. I'm also working on some characterization on conformal invariants of Einstein manifolds. And these are integrated conformal invariants, so make of that what you will. Have you ever considered private sector or military contract work? I have considered military contract work, and I considered no. I haven't considered private sector. It's not something I'm particularly interested in. I've done a master's of science in physics. Should I need to do PhD, or are there any job opportunities for me? Any job opportunities in physics are going to require a PhD. That's the bottom of it. Are you DiffGeo QFT land? Mostly DiffGeo. I dabble in QFT only insofar as it lets me do cool geometry. So like I'm interested in, so I recently wrote a paper on like a Lorentzian manifold with a closed time-like direction. And so in order to make that happen under, like, given the Einstein field equations, I needed to invoke some QFT in order to make that happen. And I wrote another paper, or there's another thing that I was doing. I wrote another paper on like some kind of QFT-ish stuff, and that involving like quantum fluctuations of spacetime. So almost like the QFT that I do is only in service to the geometry, if you will. So make of that what you will, I guess. Thoughts on the UAP Hellfire video? It looks like it hit a drone. Is there a way for someone who does not have a background in physics to share a hypothesis regarding gravity and time in a different lens? I mean, you can always share it, but almost certainly your hypothesis is wrong. Like it's just a fact of the matter that if you don't know the field, you're likely to be making mistakes, or it's likely not an original idea. Unfortunately, it's just the reality of the matter. Do you prefer working with Lagrangian or Newtonian mechanics more? I like Lagrangian mechanics more. It's more elegant. What's your take on physicists that don't believe in time dilation? I don't know that any such exist. Your opinion on the use of experimental statistics in engineering research, chemical engineering, should I take that as an elective in my graduate course? I suppose that would be important, right? A balloon that looks like it's moving due to its perspective fits the video. Yeah, sure. How can we get direct evidence of string theory when the energy needed for that is enormous? Well, you either need very, very clever experimentalists who can try to get like some sort of direct evidence in some other clever way, or you just don't. How ignorant is the general population about physics? Generally very. What about time dilation around a black hole? It's very extreme. What's your biggest hot take? I don't really have super hot takes. I mean, maybe the many worlds, maybe that I favor the many worlds interpretation. That's like considered a hot take, I guess. Are any disciplines separated into theoretical and experimental like physics? There are theoretical chemists, but they're closer to physicists anyway. Would you agree that black holes have some 4D qualities or a 4D object in some sense? Well, in some sense, everything's a 4D object in that everything exists three-dimensionally in space and then one dimension in time. But black holes are not four-dimensional spatial objects, if that's what you mean. Doesn't Lagrangian mechanics just give you the Newtonian mechanics without drawing a free body diagram? Well, yeah. But like, in Lagrangian mechanics, well, okay, not necessarily. In Lagrangian mechanics, you can do a lot more general things than just like forces. Like, in principle, Lagrangian mechanics is equivalent to Newtonian mechanics, but it's just a different way of formulating it, and I think that it's a more elegant formulation. By the way, so funnily enough, Sean Carroll is hiring a postdoc this year, and I really want that job. So if anybody knows Sean Carroll personally, reach out to me. Please. I'd love an introduction, because I want that job. Do you think the stuff found on Mars is due to ancient life? I kind of think it is, but I'm not going to make any definitive statements until we have better evidence. Where do you rank yourself among physicists in your field? Oh, I'm average. I don't think that I'm particularly brilliant. I think that, I have an outlook that perhaps gives me a different perspective because I have training in both mathematics and physics, but not so much more than that. I don't think I'm particularly spectacular. If Sean Carroll was your dad, then you would spell his name right. Yeah, no, it would be amazing. Don't tell that to Sean Carroll. Don't tell what to Sean Carroll? How well do you know astronomy and cosmology? Oh yeah, I shouldn't tell them that I'm average. Well, look, so I think that average amongst physicists does not mean average amongst averages. So I think that I have something unique that I could bring to Sean Carroll, namely that he and I both engage in public outreach, and I engage in philosophy of physics, but my background is in physics and mathematics, and I do cosmology, and I don't think that that's particularly common. But as far as like my talent goes, I think that I don't think I'm like more talented than your average, like certainly not more talented than your average physics professor, right? Because your average physics professor has tenure. I don't have tenure. How you average, the 3 laws of Newton and 3 laws of Lagrange you should be taught. Well, not amongst physicists. Sean creeping in your live. Look, if Sean Carroll's here, that'd be great. What school did you get your PhD at? I'm not telling. I'm not a physics major, but I want to learn it rigorously. Is there a way I can do that? Pick up textbooks. That's probably the best way. Which current physicist do you admire the most? I mean, I do admire Sean Carroll. I think that he does a really good job. Just as a person, he does an excellent job doing outreach. But as far as the living physicist who I think is like the most brilliant, I would say Roger Penrose. Should I study astronomy? If you love it, do it. Why don't you want to tell us what school you went to? Because then you could find out like all of my personal identifying information, because I've told you what year I graduated. I feel like picking up textbooks isn't the most helpful thing when you aren't sure how to solve things. Textbooks are there to teach you how to solve things. That's what's supposed to be in the textbook, right? What do you think quantum computing has done for research that would have not been possible either? Quantum computing hasn't done much for research, except quantum computing research. People are studying how to make quantum computers and stuff like that, and so that has an implication for quantum computing research. But I don't think that it's actually been used. I don't think it's actually been used to actually solve other problems. How equal are PhDs from accredited colleges? I mean, they're all PhDs, right? But getting a PhD from Harvard or getting a PhD from Princeton unfortunately goes further than getting a PhD from a state university, right? And that's just the reality of it. How often do you peer assess other papers? I have one sitting in my email inbox right now. If I were to pick up textbooks, what order of topics should I pick? Start with classical mechanics. Pick up University Physics by Young and Friedman, or pick up University Physics by Sears and Zemansky. Any of these standard introductory textbooks are generally written pretty well. Which textbooks do you like for mathematicians who have little physical intuition? There are a lot of, so the more advanced stuff, there are a lot of textbooks that are like general relativity for mathematicians, and they will like do like a full axiomatic derivation and things like this. which are quite nice. Quantum field theory for mathematicians. Like, so I would pick up one of those if you're a mathematician. It'll probably help. Probably be more readable. If there isn't a time operator that generates energy translation, how is QFT genuinely covariant? Well, it's so to be clear, there is a, so, okay, the question is there a time operator? And the answer is, I mean, in principle, yeah, right? Like you can have a killing vector. Like that's no problem, a time-like killing vector. If you're asking how it's covariant, the point is that you can do a computation and it will be invariant under diffeomorphisms. That's the whole business, right? If you mean why is it that there are operators that generate spatial translation but don't generate temporal translation, it's an interesting point. I'd have to think about it some more. Oh shoot. Oh boy. I may have made a mistake. Because... oh no, never mind. I'm good. We're good. Okay, we're good. How do physicists find niche mathematical theorems that describe their observations? They talk to mathematicians or they read. How much a master's in math help when it comes to physics? It would probably help, but it depends on what you did your master's in, right? What do you think about the confirmation of Hawking's area law and the primordial black hole spotted by the James Webb? I doubt that that's been seen, but maybe it has been. But I haven't heard about this. Let's see. Oh, I don't think that it did. Oh, you're talking about the little red dots. Yeah, so we don't know if those are primordial. But anyway. Is it possible for me to double jump on a really hard piece of hair? I guess. Have you read Singularity by Kurzweil? A long time ago. Your thoughts on can information be destroyed in a black hole? If it froze, is it still information? I suspect that it hasn't been. Oh, I'm gonna lose my voice. Y'all, I think I might end the live stream here because, yeah, I think I'm gonna lose my voice here. All right, y'all. So I will be back tomorrow around the same time for more question and answer content. Another Ask a Physicist tomorrow at 9 a.m. Pacific time. I will see you then. In the meantime, if you haven't already, make sure to join the Discord. There's a Discord server. There's a link in the link tree in my bio that you have to copy and paste the link. Clicking on it doesn't work. And you can also just find the link in the YouTube video that you're currently watching this on if you're watching on YouTube. But join there. You'll get some announcements about when I'm live, about when I post new videos. You can ask questions there. There's a whole group of people who can answer questions and have interesting discussions. So feel free to be there. In the meantime, have a great rest of your Tuesday. And yeah, take care, everybody.